Good afternoon, everybody. Nana. 13 students joined, including me, 14. Mahati, I request you to kindly take down the particulars. And
Okay,
if all students are there, means I will also take the print screen, but I may forget. So if you can take, it would be nice. I'm recording already. Number of, whatever I'm doing, I'm sharing also. Okay. Good afternoon, girls. It is already 2:45. Let me start the class. It is again on shortest distance. Let me share my screen. Can you all see the shortest distance document, girls?
yes, ma'am.
Yes. Okay. I just revised what all I did so far in this shortest distance, girls. Yesterday in the class, I explained to you what exactly shortest distance between two skew lines. And afterwards, what I did is I took two lines which are both in symmetric form, and then I found out the shortest distance between those two lines, and also I found out the equation of the line of shortest distance. Okay, this we finished yesterday, and what I did at the end of the class yesterday is I gave you a line in symmetric form, another line in unsymmetric form, and I asked you to find out the shortest distance between these two lines, and also the equation of the line of shortest distance between these two lines. But how? I asked you to convert this unsymmetric form into symmetric form so that both the lines would be in the symmetric form. And as I explained to you in problem number 1, I asked you to find out the shortest distance between those two symmetric lines. And also I asked you to find out the equation of the line of shortest distance. That is the first method. So if you don't want to follow the method which I'm going to explain to you, better you convert the unsymmetric form of the line to the symmetric form so that both the lines would be in symmetric form, and you can proceed with the procedure. Okay, that is one of the methods. Let us see how to find out the shortest distance between these two lines when one is in symmetric form, other one is unsymmetric form. Okay, I'm explaining to you the fresh method. Whatever is comfortable, whichever method you are feeling it comfortable, you can adopt that method. You will be end up with the same answer. Okay, so that's why I gave it as a homework, because already explained to you how to transform unsymmetric form of a line into a symmetric form. So that's why I asked you to transform this into symmetric form when both the lines are in symmetric form. By the method which I explained in problem 1, you can find the shortest distance and the equation of the line of shortest distance. Let us solve the same problem using the other method. Okay, so method 1 already explained to you. Convert unsymmetric form to symmetric form, then follow the above procedure. Now second method, the given lines are like this. One is in the symmetric form, other one is the unsymmetric form. So if you see the first line, girls, this line is passing through the point 0, 0, 0. See, x minus 0, y minus 0, z minus 0. And whereas the DRs of the first line are, see here, 1, 2, 1. Means L is 1, M is 2, N is 1. So the line 1, L1 is passing through the point 0, 0, 0, and it has DRs 1, 2, 1. Okay. Now you see the second line is unsymmetric form. So to find out the shortest distance between these two lines, the very first step is, first of all, you find out a plane passing through the line L2, girls, and parallel to the line L1. What you have to do is, you have to find out a plane which is passing through the line L2 and parallel to the line L1. That's what I put the heading. We are now finding out the equation of the plane through the line L2 and parallel to the line L1. So first of all, as we did in exercise 2, let us put the equation of the plane passing through the intersection of these two planes, passing through the line of intersection of these two planes. If this is pi 1, if this is pi 2, the equation of the plane through the line of intersection of these two planes is pi 1 plus lambda pi 2 is equal to 0. This is a very, very important formula as I said earlier. See here we are using it. So this pi is the equation of the plane through the line of intersection of these two planes, means through the line L2. So to find out lambda now, what you have to do is here, see the line general equation means the general equation of the line is ax plus by plus cz plus d is equal to 0, where a, b, c are the dr's of the normal to the plane. So what I wrote here is the dr's of normal to the plane pi are 1 plus 2 lambda, 1 plus 3 lambda, 2 plus 3 lambda. Let us denote them by A, B, C. Okay. What we need? We need a plane not only passing through the line L2, passing through line L2 and parallel to line L1. So now this plane is to be parallel to the line L1 means the normal to the plane. The normal to the plane is perpendicular to the line. Okay. So normal to the plane DRs are ABC and the lines DRs are LMN. So when these are perpendicular, you have condition for perpendicularity LA plus MB plus MC is equal to 0. What we are doing here, girls, I explain to you once again. We are finding out a plane passing through the line L2 and parallel to the line L1. A plane is parallel to the line L1 means the normal to the plane is normal to the line. Okay. So the normal to the plane pi is normal to the line L1. That is why you are getting a condition, normality condition, that is LA plus MB plus MC is equal to 0, where LMN are the DRs of the line L1 and ABC are the DRs of the normal to the plane pi. Okay, because pi and L1 are parallel, the normal to the plane and L1 are perpendicular. Now see, I substituted for L, M, N, I substituted for A, B, C. So when you equate this to 0, you get lambda is equal to minus 5 by 11. So what you are going to get now? The equation of the plane passing through the line L2 and parallel to the line L1 is given by this. Means what? You have to substitute for lambda value here. Means you will get this pi as the equation of the plane passing through the line L2 and parallel to the line L1. So now you are ready to find out the shortest distance between the line L1 and L2. How? See, you have L1 and you have a plane containing L2. So you can find out the distance between these two. How? Distance of a plane from a point on the line. Okay, is that clear to you girls? So what you're going to do now is you're finding out the distance between the two lines L1, L2 means as L2 is in unsymmetric form, you are finding out a plane containing L2. So, and this plane is not only containing L2 girls, it is also parallel to L1. So now, because L1 is parallel to the plane pi, you can find the distance between L1 and plane pi. How? Distance of any point on the line from the plane. Okay. So, shortest distance between the lines L1, L2 is obtained by writing the distance of the plane from a point on the line. So, on the line already you have a point P, that is 0, 0, 0 girls. So, what I did here is, here I took a point P on the line L1 and what I did is I took a plane containing L2. So, I'm finding out the distance of this point from this plane containing L2, and whereas this plane is parallel to the line L1. Okay, I will draw the figure and send you the material afterwards. So we are now finding out the distance between two lines where one line is in symmetric form, other line is in unsymmetric form. So what I did here is I took a point on the first line and I found out a plane containing the second line parallel to the first line, so that shortest distance between the lines is the distance of the point P, which is on the line L1 to the plane pi, and this plane is containing L2. Okay, you try to understand the technical classical words, then you can easily understand the problem. So I already gave you in previous classes that the distance of the plane from a point is this modulus. Distance is always positive. This is the formula, and you know a b c are here. A is 1, b is -4, c is 7, and d is -13. So a b c d I substituted. X1 y1 z1, the point on the line L1 is 0, 0, 0. When I substituted, I got modulus is always positive, absolute value. This is the shortest distance between the lines L1, L2. So when one line is in symmetric form, one line in unsymmetric form, what you have to do is you find out a plane containing the line which is in unsymmetric form, and that plane should also be parallel to the line L1, so that distance between a point on the line and the plane containing L2 will give you the shortest distance. I repeat, to find out the shortest distance between the lines, when one line is in symmetric form, other line is in unsymmetric form, what you have to do is you find out a plane through this line which is in unsymmetric form and parallel to the line L1 which is in symmetric form, so that the distance between the two lines L1 L2 is nothing but the distance of any point on the line which is in the symmetric form and the plane which is containing the line unsymmetric form. Okay, so this is how you can find out the shortest distance, girls. You try to remember like this the procedure, and then by using the relevant formula you can just substitute and get the answer. So first part of the question is over, girls. We were able to find out the shortest distance between the lines. Now you have to find out the equation of the line of shortest distance. What we have to do for that is I am going to find out a plane through the line L1 and perpendicular to the plane pi. Also, I'll be finding out a plane through the line L2 and perpendicular to the plane pi. Okay, so first step is equation of the plane through the line L1 and perpendicular to the plane pi. What is this plane pi, girls? This is the plane which is containing line L2. Okay, so the equation of the plane through the line L1 and perpendicular to the plane pi is this formula. So x1 is 0, y1 is 0, z1 is 0. LMN are the DCs of the line. So 1, 2, 1. ABC are the DCs of the plane 1, -4, 7. DCs of the normal to the plane. I'm so sorry. ABC are the DCs are or DRs of the normal to the plane 1, -4, 7. That they are the DRs of the normal to the plane pi. You substitute and equate that to 0. You know how to expand the determinant, girls? Like x into 2 into 7 minus 1 into 4. So minus y into 1 into 7 minus 1 into 1 plus z into 1 into -4 minus 1 into 2. This is how you can expand the determinant so that you get a plane. What is this plane, girls? This is the plane through the line L1 and perpendicular to the plane pi. Now you are finding out the equation of the plane through the line L2 and perpendicular to the plane pi. So the similar lines, how equation of the plane through the line is, this is the formula, girls. And any plane should be written like this: ax plus by plus cz plus d is equal to 0. And now what we need, this is the plane through the line L2, and what we need that this plane has to be perpendicular to the plane pi. Again, perpendicular condition. What are the DRs of the normal to the plane pi? They are here 1, -4, 7. So, and DRs are the normal to this plane are what? 1 plus 2 mu, 1 plus 3 mu, 2 plus 3 mu. So, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. See, you are now finding out a plane through the line L2 and perpendicular to the plane pi. So this is the equation of the plane passing through a line, and to get mu, he gave you a condition that this plane is perpendicular to the plane pi. So condition of perpendicularity, A1 A2 plus B1 B2 plus C1 C2 is equal to 0, where A1 B1 C1 are the drs of the normal to the plane pi, A2 B2 C2 are the drs of the normal to the plane pi double dash. So from which you get mu value, girls. So what you have to do is now substitute this mu value in this equation to get the equation of the plane through the line L2 and perpendicular to the plane pi. So we have now two planes in our hands. What are they? Equation of the plane through L1 perpendicular to pi. Equation of the plane through L2 perpendicular to pi. Okay, so the intersection of those two planes will be the line. The line, what is that line? The line of shortest distance. Okay, so pi dash is the equation of the plane through the line L1 and perpendicular to pi. Pi double dash is the equation of the plane through the second line and perpendicular to the plane pi. So intersection of those two planes will give you a line, and that line is the line of shortest distance between the given lines L1 and L2. So this is the equation of the line of shortest distance. Okay, this is how you have to find out the shortest distance between two lines when one of them is symmetric, other one is in unsymmetric form, and also this is how you can find out the equation of the line of shortest distance. Every step I highlighted, girls, what you have to do, how you have to do, and please follow the steps carefully and try to do a problem of this model. Okay, now we finished two models like finding out the shortest distance and line of shortest distance when the lines both are in symmetric and one line is in symmetric, one line is in unsymmetric. Now you're coming to a very important essay, the long answer question, girls, that is to find out the shortest distance between the two lines when both the lines are in unsymmetric form, and also you have to find out the line of shortest distance between them. Okay, so now this is the problem 3 where you have two lines which are in unsymmetric form. Because two lines are in unsymmetric form, girls, I don't advise you to change both the lines through symmetric and then follow the problem number 1, because it takes more time. Okay, so one line is in symmetric, one line is unsymmetric, you can transform unsymmetric to symmetric and then follow the procedure. Otherwise, just now I explained to you direct method. Okay, now when both the lines are in some unsymmetric form, you better follow the procedure which I'm going to explain to you now. Okay, here let us denote the first line by L1, second line by L2. First line is intersection of two planes, second line is also intersection of two planes. Okay, now what do we have here? We have to first find out the shortest distance between them, and then we have to find out the line of shortest distance between these two lines. Let me first find out the shortest distance between the lines L1, L2. For this, what we are going to do, no, I'll just explain to you. I'll find out a plane containing L1 and I find out a plane containing L2, and I take these two planes are parallel. Okay, so that you will get the planes which are containing the lines L1 and L2 and parallel. So, and you just find out the distance between those two parallel planes, which will give you the distance between these two lines. Okay, that is basically the procedure, girls. Okay, so now first I'm finding out the equation of the plane passing through the line L1. Again the same formula. See here, first plane plus lambda into second plane is equal to 0. This is the equation of the plane passing through the line L1. So I put it in the standard form, ax plus by plus cz is equal to 0. Now, in a similar way, you find out the equation of the plane through the line L2. What is the line L2? It is again intersection of two planes. So, the equation of the plane through the line L2 is again first plane plus some other mu times of second plane is equal to 0, and you just rearrange the terms like ax plus by plus cz plus d is equal to 0, because this is the standard general equation of the plane. Now you have this plane 1, which is the plane containing L1, and plane 2 is the plane containing L2. So you please say that or assume that these two planes are parallel. So when these two planes are parallel, the ratio of the drs of the normals are the same. So this drs of normal of the first plane are 3 plus lambda minus 9 plus lambda plus 5 minus lambda, whereas the drs of the normal of the second plane are 6 plus lambda, 8 plus 2 lambda, 3 plus mu. So when these two planes are parallel, the ratio of the drs of the normals is the same. So 3 plus lambda by 6 plus mu is equal to minus 9 plus lambda by 8 plus 2 mu is equal to 5 minus lambda by 3 plus mu. So all these are equal. Let them be equal to k. I repeat once again, girls, to find out the shortest distance between these two lines which are in unsymmetric form, what we are doing first is we are finding out a plane containing line L1 and we are finding out a plane containing line L2, and we are assuming that these two planes are parallel. When the two planes are parallel, the ratio of drs of the normals to the planes are equal. So this is the ratio, and this is equal to k, you say. So from the first one you get 3 plus lambda is equal to k times of 6 plus mu, from which you get equation 3. And when you equate minus 9 plus lambda by 8 plus 2 mu to k, you get second equation, equation number 4. And from the last identity, 5 minus lambda by 3 plus mu is equal to k, you get 5 minus lambda is equal to k into 3 plus mu, from which you get the equation number 5. Now you have three equations in your hand, and how many unknowns, girls? Three unknowns, lambda, k and mu. Okay, so you have to solve these three equations, girls, to get lambda, k and mu values. How will you solve, girls? I just give you a simple method, elimination method only. You first try to eliminate the product term mu k. Girls, please listen carefully. You have to eliminate mu k. So what you have to do, you add 3 and 5 so that mu k will be eliminated, and then you multiply equation 3 with 2, so it will be having minus 2 mu k, and here you have again minus 2 mu k. Subtracting 4 from 3, again mu k will be eliminated, so that you will get two more equations with only lambda and k. So two equations, two unknowns, you solve, get lambda k values. After getting lambda k values, you substitute either in equation 1 or 2 or in 3 to get mu value, girls. Okay, like this I discussed how to solve equations of this kind when we were doing copolarity problem. Once again I'm saying, girls, here you have three unknowns and three equations. The first thing is eliminate the product term uk. How to eliminate, you see, depends on the equations. Luckily here, if you add 3 and 5, mu k will be eliminated. And again from 3 and 4, after multiplying 3 with 2, you can subtract from 3 the equation 4 and mu k will be eliminated. Finally, you'll get two equations in lambda and k. Solve them to get lambda value, k value. And using lambda k value in any one of these equations, you can get mu value. So please see how best easily you can solve the equations and to find out values of lambda, k and mu. Okay, so after getting the lambda mu value, you substitute them in equations 1 and 2 to get the planes containing L1, L2 and parallel to each other. See, here we took parallel condition, no? So you are going to substitute the lambda value in 1, lambda mu value in 2, so that you get two planes like this plane and this plane. And what are these? This first plane is the plane containing L1 and parallel to this plane, whereas second plane is the plane containing L2 and parallel to this plane. So these two planes are the planes through the lines L1 and L2 and parallel to one another. I discussed already with you girls when I was dealing with the planes. Two planes, if at all they are parallel, they differ only in their constants. See here, ax plus by plus cz plus d1 is equal to 0. Ax again plus by again and plus cz only you have, and plus d2 is 0. Here ABC is 17, 2 minus 7. They are common. They are the drs are the normal to the plane, and whereas here d1 is 0 and d2 is minus 13. So you have now two planes. What are these two planes? They are the planes containing the lines L1 and L2 and parallel to one another. So to get the shortest distance, what did I say? When the planes are in unsymmetric form, find the planes containing the lines L1 and L2 and which are parallel to one another. So distance between two parallel planes, you know, that is d1 minus d2 by root a square plus b square plus c square. So distance between two parallel planes formula you must write, girls. It is positive modulus. So here d1 is 0 and d2 is minus 13. So modulus d1 minus d2 by root a square. A means here 17, b means here 2, c means minus 7. So this will give you the shortest distance. Remember, this is a very simple problem, girls, but you need to have some patience and you should be very, very careful in simplifying. So to find out the shortest distance between two lines, when both the lines are unsymmetric, first find out the plane containing L1 and then find out the plane containing L2 and take them as parallel and find out those two planes which are containing L1 and L2 and parallel to each other, and then use the formula distance between two parallel planes to get the shortest distance. So this is the first part, girls. We were able to find out the shortest distance between the two lines when both of them are in unsymmetrical form. Now, how to find out the equation of the shortest distance between the lines L1 and L2? See, already you have no equation 1, girls. What is this? This is the equation of the plane containing L1. And 2 is the equation of the plane containing L2. So what you have to do is, you just see that this plane 1, actually this plane 1 is perpendicular to this plane 6. Okay, 6 and 7, they are parallel, no? So if at all perpendicular to 6 means, it is also perpendicular to 7. So now you find out the equation of the plane which is perpendicular to 7. So the equation of the plane, if you see plane 1, see here, the drs of the normal to the plane are 3 plus lambda minus 9 plus lambda plus 5, 5 minus lambda. Okay, and whereas the drs of the normal to the plane 6 are 17, 2 minus 7. So when that plane 1 is perpendicular to 6, a1 a2 plus b1 b2 plus c1 c2 is equal to 0, from which you get lambda as 1 by 13. In a similar way, you find out the equation of the the plane which is perpendicular to the plane 6. So plane 2 is here, girls, and who normals drs are 6 plus mu, 8 plus 2 mu, 3 plus mu. So when this is perpendicular to plane 6 or 7, it is 17, 2 minus 7, no? So a1 a2 plus b1 b2 plus c1 c2 is equal to 0, from which you get mu value. So what you have now in your hand, equation of the plane through L1 and perpendicular to 6, and you have equation of the plane through L2 and perpendicular to 6. So equation of the plane through L1 is this, girls, and if it is perpendicular to 6, you got lambda value this. You substitute lambda value here and you get the equation of the plane. What is this plane, girls? This is the equation of the plane through the line L1 but perpendicular to the plane 6. See, perpendicular to the plane 6 or 7 is the same, girls, because 6 and 7 are parallel. So in a similar way, you find out the equation of the plane through L2 and perpendicular to 6. This is the equation of the plane through L2, girls. And if it is perpendicular to 6, here I put the condition of perpendicularity, no? So from which you get mu value, you substitute this mu value here, girls, to get the equation of the plane through L2 but perpendicular to 6. Now you have two planes. What are they? The planes which are passing through L1 and passing through L2 and perpendicular to each other, girls. Okay. So equation of the plane through L2 and perpendicular to 6, equation of the plane through L1 and perpendicular to 6, and these two planes are intersecting. No, that intersection is the line that is the line of shortest distance. So the equation of the line of shortest distance between the given lines L1 and L2 is the intersection of these two planes, where the first plane is the plane containing L1 and perpendicular to 6, whereas the second plane is the plane containing L2 and perpendicular to 6. Okay, very simple, girls. This problem is very simple to follow. First you find out the equation of the plane containing L1 and equation of the plane containing L2, and you see that they are parallel, from which you can get the equation of the plane, actually equation of the plane which contains L1, equation of the plane which contains L2, and those two planes are parallel to one another. So you will arrive at two equations, girls, and these two are the planes which are parallel to one another. You can identify here that you can make out that here that these two planes are parallel, and one of the planes is containing L1, other plane is containing L2. That is the first step. So first step, you have to find out the planes containing the lines L1 and L2 and parallel to one another. Whereas in the second step, you have to find out the planes containing the first line and perpendicular to one of these planes. At the same time, you have to find out the equation of the plane containing L2 and perpendicular to one of these planes. Okay. First step, you found out the equation of the planes containing L1 and L2 parallel to one another, whereas in the second step you are finding out the equation of the plane containing L1 and perpendicular to one of these planes and containing L2 perpendicular to one of these planes, and the intersection of those two planes will give you a line, and that line is the line of shortest distance between the given two lines. Okay, so we finished, girls, all the three models, finding out the shortest distance and the line of shortest distance. What are the varieties? First variety is both the lines are symmetric. Second one is symmetric, other one is unsymmetric. Third one when both the lines are unsymmetric. Okay, and your homework is already finished yesterday, the first case. Now today second case. I don't want you to do second case problem, girls, because already you worked out yesterday, like transforming one of the unsymmetric line to symmetric. Okay, today I'm going to give you only one model, girls, and you have to do two problems of this model. Okay, that model is you take two lines both in unsymmetric form and do the problems, two problems on this model and submit it. Okay. Now 15 students are there already. Girls, you have any doubt, you can enable, or you can click on your microphone and ask me your doubts. See down the status bar, you have here a camera, and also you have microphone, girls. Can you hear me?
Yes, ma'am.
Yeah. So already I recorded the lecture, girls, for half an hour. I'm going to stop the record. You have any doubts, girls, by the way? If you want, you can turn on your camera. You can turn on your microphone to speak to me, girls. Any doubts, girls? 16 students are here. Shall we close now?
Yes, ma'am.
Okay. Please do the problems and submit without fail, girls. I'm saying even if you are late, see that all assignments are submitted. Okay.
ma'am.
And do two problems today to the last variety.
Okay, ma'am.
All the best, girls.
Thank you, ma'am.